Greetings, mathophiles, and welcome to a quick video on the table features of the TI-84 family of calculators. You may be familiar with some, but not all of what I'm going to show you, and so we're just going to do two quick little things. The first is to imagine that we've been asked to graph the function y equals negative 2x squared plus 12x minus 10. Now, because you're good math people, you're going to employ some paper and pencil techniques to figure out what are the x-intercepts and the y-intercepts and where's the vertex and so on. But if you want to flesh things out a little bit to make your graph that much more precise, have it conform that much more closely to what the function actually does, a thing you can do is to, of course, enter the function in your y equals screen. And so I've entered this as y1. And then you can make a table and look at values. And the way you begin that process after entering the function itself is to go to this thing called table set, which is second window. And if you want to just make a table of values that begins at a certain place and increments by a certain amount, this is where you do that. So let's say we wanted to start by plugging in an x of negative 2. And let's say we wanted to go up by 1 each time. So basically we're plugging in integers starting with negative 2 and then increasing thereafter. We would set the delta table, which is the increment from x to x, at 1. And then we would set these two toggles, the independent and the dependent variable toggles, to auto for automatic, obviously. And then we'll just go second graph, which is the table command. And you will see the thing that we asked for. X's starting from negative 2 and increasing by 1 thereafter, plugged into this function with the y's kicked out. You can scroll it. You can even scroll it backwards past what you had indicated as the initial x. Very handy feature when you want to get additional values of a function for graphing purposes or really for any purpose. Second feature we're going to illustrate by way of looking at the question of evaluating this limit. Limit x approaches 0, x cubed plus 10x squared plus 12x minus 72 all over x minus 2. It's immediately apparent that there's going to be a division by 0. And if you plug a 2 into the numerator, you find that that yields a 0 as well. Now, some of you may know some ways of approaching this, like factoring and canceling, or like using L'Hopital's rule. But if you just wanted to investigate numerically, there's a cool thing that you can do with the table as well. So I'm going to turn off our first function and turn on the second one. So I've entered that expression as y2. And then I'm going to go to the table set screen. And I'm going to toggle down to this independent line, and I'm going to switch from auto to ask. And what that does when we go into the table feature is it allows you to just type in whichever x's you like. So if I want to explore the limit of this expression as x approaches 2, I could maybe enter a 1.9 and then a 1.999. These don't have to be in arithmetic sequence as they do when you set it up in the way that we just saw. And as you see, we're coming out in the neighborhood of 64. Can add a few more 9s, and we get that much closer to 64. We probably should check the other side of 2 as well, and we find that we're getting numbers very close to 64 also. So this is not a proof, obviously, but this is fairly strong numerical evidence that we should anticipate that this limit would be 64 or something very close to it. So that's a handy feature. Some people don't know about it, so if it was new to you, that's great. Enjoy these features. They can be handy at times. Happy mathing.